for joining me. This video is about how I compiled a massive 116 kilobyte regex pattern that recognizes every word in the novel Moby Dick. So the first thing is I'm using an adaptive Radix tree JavaScript library that I wrote, along with a Latin1 Collation library that I wrote to go along with it. The second thing is we need to split the novel Moby Dick into a list of individual words, which I'm doing with a simple regex pattern. There are other more formal approaches you can follow, but that's the approach I'm following. Once we have the list of individual words from the novel, we take each word, derive a level 0 sort key by way of the Latin1 Collation, and I'm lowercasing all of the words. You don't have to do it that way, but I'm doing it that way. And then we insert them in the tree. Finally, with all of the words in the tree deduplicated, then we use the tree's toRegex function to compile a logical expression that represents, it's an intermediate result that logically represents the regular expression. Then the second part is we call the serialize function that comes with that intermediate result. And that translates the intermediate result data structure into a single pattern string that is compilable with popular regex engines, such as the JavaScript one. I'm also writing that string out to a file just because it's interesting, and it's about 116 kilobytes. Finally, we take the regex string that's produced in the second compilation step, and we convert it into a fully anchored pattern, and then we compile it with the JavaScript regex class. So we have our JavaScript regex object now. Then we go through and we iterate through all of the words. I'm also doing some bookkeeping to keep track of any words that may have code points that are out of range of the Latin1 collation. There's two things you can do. As I do, you can simply ignore it and force your test words into the Latin1 collation range. Another thing that you can do is you can, before you put your words into the Latin1 collator, you can remap any out of range code points in a custom way. So actually, I've looked at it, and the only out of range code points, as you'll see, are mostly simple things like typographic apostrophes and whatnot. So that's fine. And so finally, we test if the word is matched by the regex pattern, and if so, we keep track of that with a matches counter. And finally, we dump some statistics for how long it takes and how many matches we have. Okay. So let's run this so you can see. Okay, so here are the results. You can see all of the words in the original list do get a match with the compiled expression. It took about 144, 145 milliseconds to compile the initial expression from the adaptive radix tree, to compile the pattern string from the intermediate result was about 75 milliseconds, and finally to compile the JavaScript regex object from the pattern string is about 6 to 7 milliseconds. Okay, and then here I'm dumping, the words with out of range code points, and as you can see, they're just mostly typographic hyphen characters and that OE character. So I didn't do any custom remapping, but if you want to, you can do that. Okay, and I will show you the pattern string that was written out to a file. This is the massive trie-style regex pattern that was compiled from the adaptive radix tree, and which matched all the words in the novel. So there you have it. Thanks for watching.